Okay, as we all know, the equation e to the x is equal to 0, this right here has absolutely no solution, not even in the complex world. But what if we have e to the x is equal to 1? And you might be wondering, they are the same thing, right? Because I just kind of exponentiate both sides. Or you can also look at it like this. E to the x is equal to 1. Why don't we just natural log both sides? And then this and that cancel. So we just get e to the x is equal to ln 1, which is 0. So of course, this right here also has no solution, right? I was wrong. Check out Wolfram alpha right here. It does have some solutions. In fact, infinitely many. I'm going to show you guys how does Wolfram alpha end up with that. I don't know if you agree with the solution, the answer or not, but it's really cool, so check this out though. So here we go. E to the x is equal to 1. The idea is that if you don't have 0 right here, you have more things to work with. You have this 1 to work with. How do we work with 1? Let's go to the complex world. So have a look. This is the complex plane. So this is the real axis and this is the imaginary axis. 1 is somewhere right here. What we are going to do first is we are going to convert this into the polar form. First, we need a length from here to here, r, and that's just equal to 1. And then we need the angle. Well, the first angle is just going to be 0, but don't forget that we can rotate this direction, which is 2 pi, or you can go the other direction as well, as many times as you would like. So the angle is just 2 pi, and I will let you just follow Wolfram alpha's notation. You multiply by any integer, but they use C1, not doing calculus integrals, right? I will just use C1 here too. So that's what we have. What we are going to do is, we're just going to rewrite the 1 into the REI theta form. R is just 1, but we are going to have E for the base, and then I, the complex number, times the theta, which is 2 pi C1. Most of the time people use N or M, but Wolfram alpha, right? Anyway, so we have e to the x is equal to this right now. And of course, 1 times this, just that, so that's what we have. What can we do next? Well, let's now take the ln on both sides, right here, and of course right here, and cancel the first e. And because we have all the possibilities, so we're good, well, we don't need to add anything else. Now we are going to get e to the x equals that, which is I times 2 pi c1. And now you might be wondering, should we just take ln on both sides? No, not yet. Because why? Because right here we can say that's multiplied by 1 again. But what exactly is 1? 1, it's the same as what we just did, which is 1 times e to the I times angle, which is 2 pi. But this time this 1 is a different one than the one earlier we used, all right? Instead of c1, let's put on c2. Again, just another integer. And then right here, let's take the natural log one more time. Cancel, cancel. And then we are going to get x, which is just a complex number. And then right here, of course, this is a product of this thing and that thing. So let me write this down right here first, which is ln of I times 2 pi c1. And then we can say, let's go ahead and add ln of the other. So ln of this part, which is e to the I times 2 pi c2. Now this and that cancel. Ladies and gentlemen, x equals ln of, I'm just going to rearrange it. 2 goes first, and then I, and then pi, and then c1, and then we add. No more ln, this is just 2 goes first, and then pi, I, pi, c2. Here are some conditions. First off, we have c1 inside of natural log. c1 cannot be equal to 0. Otherwise, ln 0, it's never defined, right? So we'll say c1 and c2, they are integers with the extra condition that c1 is not equal to 0. And that's the solution that Wolfram alpha gives us. Do you guys agree? Well, let's check this out. I'm just going to pick an easy number for C1 and C2, and that's what we have, right? So let's see. I'm just going to say let C1, C2 equals 1. Right? So I'm just going to let C1, C2 equals 1. So X is, that's just Ln. And I know we can break this down, but because C1 can be negative, whatever, it's really complex, I'm just going to leave it. Anyway, we have Ln of 2I pi plus 2I pi. All right? Now, this is really cool. Have a look. I'm going to put this back here. So, we will have e to the power, which is Ln of 2I pi plus 2I pi. What's this? First off, this is just e, and then we can do rule of exponents. This is e to the ln 2I pi times e to the 2I pi. Check this out. What's e to the 2I pi? It's just equal to 1. You can use this here, or you can use that. So in fact, this is just equal to 1. And what's this? Well, they cancel. Oops, wrong color. They cancel. So it's just 2I pi times 1, which is just 2I pi. So we actually get, whoa, so many colors. I haven't solved like a crazy equation like this for a long time. Anyway, this is e to the 2I pi, which is really just equal to 1. Oh my god. So e to the this number is equal to 1. I don't know if you guys agree, but that's how you get the solution from Wolfram Alpha. Hopefully you guys all like this. That's all.